All right. Let's do this. So today's the first day of Task 2 content. Task 2 is out. I won't go through the whole thing explaining it, but feel free to take a look, get started on that. After today, you should pretty much be able to do the whole thing, let's say. And a lot of the content weeks for this semester will follow kind of like this structure where Monday, I'm telling you everything you need to know about the topic. And then Wednesday and Friday, we reinforce those topics, show more examples, go into implications of the concept. Because you could technically do the homework after today, but it'd probably be pretty tough because it's all brand new. And I've only done surface level explanations of everything. But I like to get everything out there right from the start. And the programming task has been out for a while, but the grader was released. When did I finish that? Sometime over the weekend, Saturday or Sunday, I don't remember. But the grader is out as well. So if you did get started on the assignment, get submitting and see how you're doing. All right. Objects and classes. Let's do it. So this is, I kind of foreshadowed this a ton. It's where a lot of the real core content of the course starts, I suppose, at least in my opinion. Let's just get into it and we'll show you. So let's talk about classes and objects. We've been working with classes right from Hello World, where we have to say class, hello world, but I've never really talked about what that means. I just said it's a container for our code. All your code has to go in a class, and I left it at that. So let's talk about the primary use for classes, which is to create objects, which we've dealt with a little bit so far, just a little bit. We've been dealing with some objects in the form of array lists and hash map and technically strings, but I kind of sweep it under the rug that those are actually objects, and so does Java. It kind of hides the details that strings are actually classes or that are actually objects. But array list is a class, and we use that class to create objects. Hash map is a class, and we use that class to create objects. And we create objects using the new keyword. So when we say new array list, we're creating a new array list object. So we've been using objects, I would say all along, but since like 2 weeks ago. I can't believe we're already on week 4. I guess since the first week's only half a week, it's not as crazy. But let's see how this works. And we're going to create our own classes that are used to create our own objects. Let's do it. So for the example today, we're going to create a player class that has 3 variables. And I'm thinking of a player like in a video game where we have a maximum number of hit points, our current HP, which is the hit points that we currently have after being damaged or in healing or whatever, and then a name for this player. So just a string for a name. And there it is. Yay, we're done. That's our first class, not our first class, but our first class that's used to create objects. So let's talk about what is going on with this code, with this player class. And a class in general, or rather an object, I guess, is a container for state and behavior. We didn't really have state in our classes, but for our objects, this is going to be more important. Our state is a collection of all the variables in that object, and our behavior is a collection of all the methods in that object. So an object is a collection of methods and variables in one container. Some people even like to think of objects as data structures because they are storing these 2 things, state and behavior, methods and variables. I'll use those somewhat interchangeably, state for variables and behavior for methods. But this is the general concept of an object in any language is a collection of state and behavior. So an object can be in a different state. Technically, this is true for classes as well, but we never bothered putting variables in our classes, and we're not going to. Actually, I take that back. We did. One time when we created the epsilon variable, that was a part of the state of the class where it was defined, but I don't want to go down that rabbit hole too much. Our objects will have both variables and methods, though. So this player class is declaring variables outside of all of the methods. I almost misspoke again. It's the second time we're seeing this, but the first time I glossed over it real quick with epsilon. Now it's going to be forefront, very, very important for us all to understand. We're having variables that are outside of all of the methods, And whenever we create variables outside of all the methods like this, these variables belong to objects that will be created from this class. When we created variables outside of all the methods that were static, and today we're going to really hammer down what the difference between static and non-static is. When they were static, like the epsilon, that was part of the class itself. When they're non-static, they'll be part of the object. So we're declaring these variables outside of the methods and without the static keyword here. So these are going to be what's called instance variables. That's what I'll call them throughout 116. They're also called state variables, fields, object variables. There's tons of names. I don't know why, but these things have, there's other ones I can't think of and I didn't put on the slide. But these have at least 5 different names that you'll hear throughout your career. Some people just call them different things. I don't know why. And even me, like I'll call them different things in different contexts. In 116, I call them instance variables because I think that's more descriptive of what they are. An object is an instance of a class. Those instances have their own instance variables. But then in 312, I'll call them fields because at that point I just want to say one syllable instead of a whole mess of syllables. So I'm not even consistent with myself. But these are instance variables. They're variables declared outside the methods, and they belong to objects of that type. So I guess I am part of the problem on this one. I'm not sorry, though. I kind of want to call them fields everywhere, but field just is not descriptive at all. I like it because it's one syllable, but it gives you no indication of what these things actually are, in my opinion. Fields, it comes from math. Math calls them fields, so. All right, and then we have this very special method called a constructor. This is our first constructor that we're going to see. A constructor is a special method that is part of a class that is used to create objects. We'll call this method to create objects of this type. And a few things to note about these constructors is, 1, there's no return type. Our first method we're ever seeing without a return type. 2, the name of the method has to be exactly the name of the class. This is the only method that we'll see, at least in 116, that starts with a capital letter. Your method should always start with lowercase letters to follow naming conventions. This is the only one that'll start with a capital letter because our classes should start with capital letters. So we're going to have one method with a capital letter. It's always going to be our constructors. Other than that, it looks like a regular method. The other difference is how we're calling the method. We do not call this method like a regular method. We don't just say player of arguments. We have to use the new keyword. Whenever we're calling a constructor, we're going to use the new keyword. So if we want to create a player object calling this constructor, we're going to say new player, new, and then call the method just like you always would. Player, give it an argument matching the name parameter, give it an argument matching the max HP parameter. So new is going to say, hey Java, I'm about to call a constructor. You know what to do with this. And then give it the constructor method call. And then this method, what it actually does is initializes our 3 instance variables to whatever values we code it to be set to. We're going to start our players at full HP, so I'm only taking the max HP and setting HP and max HP both to that value, and then the name, setting those instance variables. We have this keyword this. Any questions on this? I'm just going to throw it all out there. Like I said, Monday I just throw everything out there, and then we spend the rest of the week digesting. So if this is a bit much, please ask questions. And I'm always watching the lecture channel. Nobody's chatted in this lecture yet. I am connected to the right internet, and it was working just in the previous lecture. All right, what's up? Sorry, what was that? Right here where I'm saying int max HP, but max HP is already an int. So this, and I did this on purpose because it's tricky to make this point, I'm glad you asked, is this max HP, the parameter, is a different variable than this max HP, the instance variable. These are 2 different variables. They happen to have the same exact name, but they are two completely different variables, so I do have to declare each of them independently. And I could have named this whatever I wanted. Sometimes I like calling this like max HP param, just to make it clear that it's a parameter. Here I want to make it the same name, just to show you that those are two different variables. And a lot of this will be more clear in the memory diagram as well. But I'm just getting all of the content out there, all the concepts. Okay, another concept, we see this keyword this. It's a brand new keyword. This is something that's historically confused, I want to say students, but just people, consistently confuses developers, software developers. Over the years, the keyword this. Very tricky concept, and I'm going to talk about it so much. All of you are going to fully understand what the hell this thing does. This is a keyword that stores a reference to the object that called a method. In the special case of a constructor, this is a reference to the object that is being constructed. So when we call this constructor, we're creating an object on the heap. Like our array list and hash map, we had an object on the heap. We're getting an object on the heap that's stored at some reference. This stores that reference. It's like a variable that we don't have to declare. It's just automatically always there for every single non-static method anywhere. We will always have this keyword this, which stores a reference to the calling object or the object being constructed. Yes. Yep. And there's a little bit of a tricky edge case. If I left off this dot and just did max HP equals max HP, I would be reassigning this variable to its own value, and I wouldn't get the effect that I want. I have to do this dot to get the instance variable if I reuse that variable name, which I purposely did in this example. But if you don't do this dot, I don't even want to go down this one, but so many of you ask this and do it. If you leave off this dot, Java will try to look for a variable that's part of the calling object that matches that name. But if there's something in a smaller scope, like in this case, that matches that name, it'll find that one first. So I like to get in the habit of always using this dot, just to be very clear with my intentions and avoiding any things like that. Some of you will not type those 5 characters because you just don't feel like it. I mean, that's fine as long as your code works, but it is a little less clear what your code is doing. If that doesn't make sense to you yet, don't worry. We got to understand what the hell this even is first before we start using shortcuts. Okay, and we will, like I said, have many, many conversations about this moving forward. That's your first taste, your first introduction to it, which is technically everything you need to know about that keyword, but oh my God, that would not make sense if I left it at that. We can also initialize variables as we declare them. So if we have some initial values that we don't want to set through the constructor, we can do max HP equals 10 right when we declare it, HP equals 10. If we want every single player in our game ever to start with 10 max HP, but if we want to have players that start with different levels of max HP, we'll take it as a constructor parameter, so whoever's creating these objects can say, I want to create a player that has 20 max HP, I want another player that has 100 max HP, and let them choose when they create the object what they want to initialize the max HP to. So if we don't want to set these instance variables to different values on a per object basis, we have this option. I won't do this too much throughout the semester, but this is an option. If that makes sense in your coding, especially outside of the class, knock yourself out. Go for this. It's a little less code if that is the use case that you have. We're not going to do that. And we have our second, just because I did that private final, static, epsilon, double epsilon, all those keywords. So I kind of introduced a bunch of keywords in that one line at one time. But our second instance of private, and the first time that I actually care about you understanding what private means. Private means that you can't access these variables outside of this class. So any code inside the player class can access these 3 instance variables. Okay, that means reading them and writing to them. any code outside of this player class, so outside of the braces that define this player class, cannot access these three variables. Cannot read them, cannot reassign their values, can't do anything. It's like they don't even exist to the outside world. This is something we call encapsulation. We want to hide the details of how we're storing this data and then let other people access our data and modify our data through method calls. But this is what we'll do in Java. I say very common in Java on the slide, but you should just do this in Java. If you're coding Java, you should have private instance variables. The way the language is set up, it's just the way that we do. I can't leave it at that. But on the next slide, I'll explain it more of why we do this. But in Java, do this. In other languages, if you've done object-oriented programming or OOP, which is, now that we're talking about objects and creating objects, that's our umbrella term for it. If you're doing OOP in other languages, you might not see this, and that's because those languages are structured differently. In Java, we're going to have private instance variables. As at some points, you might see protected instance variables. Instead of public or private, there's another one, protected. There's also default, which is not as useful, but you should never have a public instance variable in Java. Never is pretty strong, but you know what? In this case, I'll go for it. If you see a public instance variable, it's probably final. If you have final in public, that's fine because it's a constant. It can't change. That's fine. But any variable that can change should be private or protected. Yeah, and then use getters and setters. It seems like fake encapsulation. And getters and setters, since it was brought up in chat. So how do we actually access, how do we make use of the data? Our objects have state and behavior. What's the point? If the state's all private, what's the point? Why even bother? Well, we are actually going to let everybody access the state and modify the state. So what was the point of even making them private to begin with? It's kind of the cyclical logic that we have. But first, let me introduce what these things are. These are getters and setters, or accessors and mutators, if you want to be fancy about it. I don't like being that fancy. Getters and setters, which are going to be used to get the value of an instance variable and set the value of an instance variable. These all have the same structure, like get HP takes no parameters and returns the value of the HP instance variable. Set HP is going to take an int and set the value of that instance variable to whatever int you gave it and return void. So the setters don't return anything, and they're just going to set the value of the instance variable. And we're going to see this a lot now that we're talking about OOP. We're going to see a lot of methods that return void that we call for their side effects. The only time we saw this so far was in a method that printed to the screen. It had the side effect of printing to the screen. Now our methods that return void are going to have the side effect of going over to the heap and changing the value of an instance variable of an object. That's going to be our primary side effect that we call these methods for. So we're going to start seeing a lot of methods that return void that actually do stuff. They actually have an effect on the state of memory of our program. So get used to seeing that. All right, but why? The big question of why the hell would we even do this? Is put for arrayless hash map a setter? Not really, but if you want to think of it as a setter, I wouldn't be too mad. It's not a setter because it's not directly setting the value of an instance variable, but it does change the state in a set kind of way. I don't know. But arrayless does have a setter where you can say set the value at this index to this value. That would be a true setter. Okay. So why? Why would we ever do this? Because this is always frustrating. This frustrated me when I first learned Java, and it's like, why? Just let me access the variables directly. This is pointless. Well, I promise you there's a point to it. So here's my pitch, my selling point to why we would have getters and setters and private instance variables instead of just public instance variables and let everybody modify them all willy-nilly, is control. We want control over our code. We don't want outside people being able to break our code. And in this case, in this example, those outside people are going to be like other members of your development team. You're out there in industry, you got a team of a dozen people all working on the same project. you're writing code that other people are going to call. Other people are going to be creating objects of your class type that you created. They're going to be saying new player and then modifying that and doing whatever they want to it. And they end up writing code, say you have public instance variables, and they write code that says my player object dot HP equals whatever. And they're manually setting the values of your instance variables directly. And then later on, you're writing your code, you're working on the project, and you realize you have bugs in the project because some people on your team are setting HP to something higher than max HP because they're just doing object.hp equals 1,000,000,000. And maybe they're doing it on accident, like maybe they have some math, some equation or complex method that spits out a number, and then they set that to their HP instance variable. And you don't want them doing that. You want some check where it says, if somebody's trying to set HP to something higher than max HP, I want to set HP equal to max HP. If you already released your code with this HP being public, and people already have code elsewhere in the project that are setting it to a value higher than max HP, you're screwed. Like, you can't make that. I mean, you can make that change, but making that change is tough. You got to go to all of the code everywhere in the project where anybody sets HP and tell them, hey, you got to change your code to use my setter method now because I want to add some data validation to this because y'all are writing crappy code that's breaking things. You would have to go to everybody and change every case everywhere in the repo to use your setter method with validation and then change your variable to private. So even if we don't want to do anything like this, like data sanitation on a setter, even if we don't want to do this right away, like for example, max HP, we have no checks. Get name, we have no checks. Even if we don't want to do them right away, we leave ourselves the option to add validation and formatting on the getters later on. So for example, if we have a getter, say we have something that's storing a timestamp, and we have the timestamp storing, in whatever format, and we want to change that format. On the getter, we want to say, well, we don't want to just send a raw timestamp. We want to format this into month/day/year, and then the time or whatever. We can make that change in the getter and format our data however we want it to be formatted. Maybe somebody wants to change pounds to kilograms. We can make that conversion right in our getter if that's what the user wants. But if somewhere else in the project somebody's saying dot weight or dot mass, depending on what units we're using, and just takes that value directly, now it's up to everybody else to do that formatting, and if it's inconsistent formatting, we just don't have any control over that anymore. But if we have getters and setters, and everybody who ever gets HP is calling this method, we can change this. Maybe instead of just the raw HP, we want to return this as a percentage of HP to max HP. Maybe we want to return that instead. We can just make that change here, and now everybody else, without even modifying their code, gets the new values, and hopefully they're expecting that new value, and it doesn't break things elsewhere. But that's why getters and setters is control. We want to be able to control how our code is used, mostly so people can't break our code. A set max HP example would be somebody tries to call this constructor with a negative max HP. We're just not going to let them. We can add a check right here. If max HP less than 0, set it to 1, however you want to handle that situation. But you don't want players running around your game with negative max HP because they're not going to have fun playing the game. They're just, or they'd find an exploit. Maybe they'd become immortal. It's not something you want. So getters and setters to the rescue. Hopefully I sold that enough. If not, you still have to live with getters and setters if you're coding in Java. It's just part of the Java ecosystem. Other languages, just to wrap up this conversation, other languages on their instance variables, you just make them public and let everybody access them however you want them to. And then languages like Python have a way to retroactively have the player.hp equals whatever, have that exact code implicitly call a setter method. Even though it's using the assignment operator, you can add a setter retroactively and update all that code without anybody else having to actually make any changes to their code. So you just at the point where you need a getter or setter, you just add it, and it just works. Java doesn't do anything like that, so we got to set it up right off the bat, even if we're not going to take advantage of it. Okay. I'm done justifying getters and setters. And you can call your getters and setters from your constructor. This isn't always recommended to call your getters and setters from your constructor, but if you have some data validation, especially, like set HP here with the data validation, I want that data validation on my setter, and I want it on my constructor. So that's an instance where I would call my setter from my constructor. But if it's like max HP in this example, and you want to just have the constructor say this.max HP equals max HP, like we had on the previous slide, like this, that's fine. And then your setter can have the same line of code just setting that variable. That's fine too, depending on what your exact use case is. For the memory diagram, I'm going to use the setters in the constructor just so I have more stack frames to talk about. On your homework, when you're checking the ratings to see if the rating is valid, it has to be a 1 through 5 int. You're going to have some validation code that makes sure that it's 1 through 5, and if it's not, you're going to set equal to -1 to indicate an error. And that has to be in your constructor and your setter. So instead of writing that validation code twice, which whenever we're duplicating code, that's generally a sign that we should be doing something better. Instead of writing that code twice, or cut and pasting it is more likely what you'll do, is write it once in the setter, and then in the constructor, just call the setter. And then in your reviewer class, you're calling the constructor, which calls the setter, which has the data validation. Write that code one time and get the validation anywhere you're setting in rating. Yes? Yes. So the constructor, and I got in a debate with some students last semester on this one, but the constructor with the keyword new collectively is going to return a reference to the object that was created. So that's why we can say array equals new array list. That new array list is going to resolve to that reference, and then that reference is stored in the variable. There's a debate of whether the constructor is doing that or whether it's the new keyword that's doing that. I argued it's the constructor, but there's an argument to be had that it's not the constructor doing that, it's the new keyword. But either way, new, we're not calling the constructor without the keyword new, so either way. Bless you. Yeah, those are a lot of good questions. Like you said, I don't want to get too far off the beaten path, but some of those questions don't have how do I word this? Don't have like de facto answers. It's going to be up to each team to decide how they're going to handle each of those situations of like where's the line of responsibility? Is it with the setter or is it with the caller of the setter? Who's responsible for the data validation? Each team's going to have to decide that. You have your design meetings and you say this method is going to be responsible for it or whatever. But it's going to be like case by case, team by team, where to draw the lines. But you should, I would argue, if you're coding in Java, you should at least have your getters and setters, because then you always have the option to change your mind later. Like things change. We want to have that option. The instance variables were accessed in the constructor using this keyword. On the tracing tool, will you need to include multiple this keywords? No, you just have one this keyword in the stack frame. And we'll see that when we get to the memory diagram. And then this is used to access each method in this case. So, oh, no. I updated this slide. Do I not have my updated slides? I fixed like one typo and I changed this image, but I guess my changes didn't take. Damn it. Oh, yeah, because I never did push it. Never mind, I know why that happened. Because I didn't finish the tracing tool memory diagram on the slide, so I didn't push. Okay, anyway. Nothing in this class uses the keyword static. I talked about it a little bit with the instance variables because I was comparing it to epsilon, but now this is the slide where I really want to talk about this. Nothing in this class uses the keyword static. Up until today, everything used the keyword static. So the difference is non-static methods and variables are going to belong to objects of this type, the player objects. Static methods and variables belong to the class itself. So before we were talking about objects, everything belongs to the class, so everything was static. So we had static methods. Whenever I said static method means we don't have to do any extra work, that means you don't have to do like new class name, and then through that object call the methods. Like for an array list has non-static methods like add and size. We say new array list, store that reference in a variable like array, and then array dot size, array dot add, array dot get. We call those methods through the reference to an object instead of through the class. Whereas our problem set on task 1 in our testing, it's import problem set the class dot sum of digits dot best key. It's through the class itself because those were static methods, so we call them through the class. Non-static methods we call through objects of that class. That's the big difference. Static, class, non-static, object. That's our big difference between static and non-static. So everything before now was static. Almost, I'll put the almost there because there's a few things on task 6 that will be static, but almost everything from this point forward in the course is going to be non-static, to the point where if I say method or instance variable, I just mean non-static. You can assume that I mean non-static from here on out, unless otherwise specified. So if I say write a static method, then I mean static method. If I just say write a method, that means non-static. Don't use the keyword static. So starting with task 2, there are no static methods on task 2 at all. Everything's non-static. So you shouldn't be typing that keyword static almost at all from task 2 forward. Again, with the exception of task 6, there's a few static methods. And I think one on task 7, there's a static method. So it didn't make sense for those to be non-static. And our methods will still be public, but our instance variables will all be private. In fact, no homework is even going to say that create an instance variable named whatever, because in my testing, I can't even access your private instance variables, so I don't have to tell you what to name them or anything. You should just know that you need instance variables, and you can name them whatever you want. So no more static methods or variables unless otherwise specified. And what we've done here is create a brand new type in Java. We've had a few types that we've seen: int, double, boolean, string, array list, hash map. Those are all types, and we talked about every variable needs a type, methods need return types, all this good stuff. What we've done is create a whole new type called player. We've created the player type through this code. That means anywhere where we've used any type so far, we could use the type player. So a class defines a type, and now we can create objects of that type, and we can create methods that have parameters of this type. We can create variables of type player. We can create methods with a return type of player, and we can create array lists, hash maps that have type parameters of type player. Anywhere where we could use our other types, or other non-primitive types, I should say, we can use the player type. Brand new Java type that we just created, something that did not exist in the language, but then we wrote this class, and now it does exist in the language. So very powerful stuff. Paul pointed to this too, but very powerful stuff that we can do with objects in classes, because we're creating brand new custom types with custom state and custom behavior that do whatever we want them to do. Very powerful stuff. Oh, I went back a slide when I whacked the board. And in terms of memory, it's only our primitive values. I've mentioned this a few times, but now we can really talk about it. Only our primitive types are stored as values. So when we have a variable on the stack, or even an instance variable, all of our primitive types and only our primitive types are stored as values directly. This includes double, int, char, boolean. We're going to pretend that that includes string. We pretend that strings are stored by value, passed by value, assigned by value, even though they're not, but it's complicated. I don't feel like talking about it in 116. Unless you want to come to office hours, I'll talk about it all day. And we're going to pretend that our wrapper classes for the primitives are also stored by value, which they often are. After these types go through the compiler and spit out the other end as Java bytecode, they're usually primitives at that point. By the time your code is actually executed, they're usually stored on the stack as values directly, even though they aren't technically in our code. Everything else is an object on the heap that's stored by reference, passed by reference, assigned by reference. Absolutely every other type. Every single type that does not start with a lowercase letter, unless, with these few exceptions that we have here, are objects on the heap, and what's stored in variables of their types are references. This includes array list, hash map that we saw already, and every single class that you write, objects of those types are stored on the heap as objects, and then we only store references to those objects in our variables. The TAs are destructive back there. I can yell at them. Just let me know. They look like they're talking. Just checking. You're giggling a lot. I just want to make sure it's not noisy. I can never, when somebody's talking, it's hard for me to hear them down here. Sometimes I can, and that's when it's real bad. But if somebody's being destructive, I don't know, stand up and point to them and be like, that person's being loud, so then I can yell at them. That'd be perfect. But if my TAs are doing it especially, I really want to know, because they should know better. They should be being perfect. All right, any questions on this? Oh, I have my asterisks here. I'll briefly point them out. The string one I've been talking about since day one. Strings actually go on the heap. But once we put our code through the compiler, I mentioned a little bit of this just now, but once we put our code through the compiler, it's hard to predict what the compiler, unless we really dive deep and study the compiler, what each version of each compiler is going to do specifically with our code. So by the time it comes out the other end, some of our objects might end up being stored on the stack and passed by value. It gets weird with all the compiler optimizations that they do. They're very sophisticated pieces of software. So when we're doing our memory diagrams, we're going to pretend everything works the way it should work in theory, which is the way that everything behaves, which for us programmers, we only care about how the things behave. We want a nice mental model of how things behave, even if what's actually happening in the specific locations in memory are a little bit different from what specifically happens. It's still going to behave as though every object is going to behave like it's passed by reference, except strings. So that's the way we're going to model them, so we can understand how our code is going to work. Questions on any of this? The next thing is a memory diagram. Any questions on any of that? That's like all the theory, all the concepts, really for the week. The rest of it's implications of all these concepts and reinforcing it mostly through memory diagrams so we can understand what the hell we just saw. This is your first time, if you didn't do AP Java in high school and this is your first time seeing objects in classes, you should be thoroughly confused at this point. So if you can formulate that into questions. Otherwise, we can just let the memory diagram rip. Yep. Yep. In IntelliJ, if you right-click in your class and do generate constructor, and then it'll let you select the instance variables that you want as parameters. Okay. Ready for a memory diagram. I'll leave the ones on my slides. I'll update these slides with the tracing tool memory diagram. I'll just put the final product out there like I did for the other slides. I ran out of time and only got this far doing it right before lecture, and then I realized there was other stuff that I forgot to do, and I'll get it updated. But let's wipe this, start clean, and do a memory diagram for this. But you can look through my slides if you want that. It has my bullet points with my commentary going through the memory diagram. So if I do forget to say something going through it like this, you have that resource there. But other than that, Zay, do you want to cover this? It's actually, it's your stuff too, your memory diagram too. What? Not really. You're supposed to be like, hell no. You're not supposed to actually take me up on it. All right, let's do this thing. You can yell at me if I use the tool wrong, though. Okay, so let's go through this. And I got to figure out the Zoom. Oh, perfect. I got TAs in the back. Can you read this? No? All right. Tell me when. This one or the one before it? Okay. And that gives me the whole thing in one screen. Cool, I can see all the code. All right. Oh, but when I scroll the stack, I'm going to lose the code. Oh, no, I won't. All right. Let's do this. We will need heap. We won't need I/O. Let's resize it like this. And let's just let it rip. Light mode. I think light mode's easier to see in lecture. I think I'll leave it on light mode, but I killed the menu anyway. So, all right. So let's do this. We start at the main method. Always, always, always. So main method. Oh, this is because I copied it from the slides. My braces don't line up exactly. Let me grab the. I don't want to mess around with that. We're going to leave it. All right. So we start with the main method. New stack frame main. And the first thing we're going to do is have a variable P1, which is going to get the value that's returned from the constructor. So we have our first constructor call. This is the first thing. This is the very first thing, right, that we're doing with memory diagrams that you have not done in 1.15. So here we go. New memory diagram content. Finally. Let's do it. So we have a constructor call. The thing you got to remember about constructor calls is they're just method calls. They're a little bit different, but they are still method calls. So that's a new stack frame. The name of the stack frame is the name of the method. The name of a constructor method is the same as the name of the class, but it's still right there just like any other method name. So player. And this is going to return to this variable just like before. And then next is going to be actually, not quite next, but we're going to create an object on the heap. I'll finish that sentence when we get back to it. And this object, we're going to put the name of the object. This is where we would put array list or hash map, or in Python, this would be list dictionary. Here, we're going to put the type of the object. This is an object of type player that we're creating. So we're going to name this player. That's the type of the object, an object of type player. The parent is going to be the constructor stack frame, and that's going to color code your object so you know what constructor constructed, what constructor stack frame and method call created this object in particular. When an object's created on the heap, it's going to have space allocated for all of its instance variables. They won't have values yet, but all the instance variables will be created. So max HP. I still have to go in the menu to create new variables in objects. HP. I like the create new variable button here, though. HP and name. So we have our variables with no values yet. And then we'll see the values populated as we call these setters. And now finishing my sentence that I tried to start earlier, we have our object, which means we have a reference number. The first value, variable, keyword, I don't even know what to call it. But the first thing we're going to put in any stack frame of any non-static method, which is pretty much every method from this point forward in the whole semester. So from your first memory diagram quiz, which is going to test this stuff, the classes stuff, classes and object, from your first memory diagram quiz, every single method, except the main method is static still. The first thing is going to be this. We're going to put this in our stack frame as though it were a variable, so we know what reference this stores. For a constructor call, this is a reference to the object being created. So we have OX002, which is a reference to this object that we're currently creating, that we're currently constructing. So this is always the first thing in your non-static stack frames. Okay, and then our parameters. Then after that, it's like a regular method call for the most part. It's like a regular method call. We have our parameters, name, which gets the value dark Cecil. Variable is going to travel around a little bit, so I'm going to copy it. We have max HP, 10. And then this method is going to call another method. This is our first use case of the this keyword. So this is a reference. Whenever we have a reference and we see the dot operator, that means I know you're a reference. This is storing a reference just like it were a variable storing a reference. It's a keyword that's storing a reference. It's the same thing. So this dot is going to say, hey, reference, take me to your object. We're going to travel to the heap to this object, and we're going to call set max HP from this object